Yeah, hello and welcome to ELC 2B, which is the second course in AC circuits. What we're going to do is we're going to review a little bit about what we've gone through, starting with the DC circuits. We'll look at, again, reviewing the Ohm's law, going all the way up to reactances and frequencies and capacitors and inductors and phasors, and then we will get into the math tomorrow, which a new math, okay, which deals with imaginary numbers. But to get started, I'd like to figure out where we are currently with respect to current technology. And to do that, we'll talk about the iPhone. The iPhone, without a doubt, is a representative of where our current technology is. It's really a wonder tool. We can do so much with it. Okay, first of all, it's a telephone. All right, so we can call somebody on it. And secondly, we can look through the internet with it if we're tied to the web. Okay, we can do we can take pictures with it. And we can do some fancy things with it. Send photos, send a lot of information on it. All right, and we can talk face to face and so forth. All right. So how does it work? So with respect to what we've learned so far, what is it about that's in the iPhone that we know so far? Well, this particular iPhone that I have is powered by a 6.8 volt battery. Okay. Well, if we're talking battery, then we know right away that we're talking DC. So we've got DC functioning in this iPhone. Okay. DC circuits. What are DC circuits? Well, basically, they're a battery with a lot of resistor networks. Okay. There might be some capacitors that we put in there that we charge up, or some inductors that we also similarly charge up. But mainly, DC is concerned with basically resistors. What does resistors do? What do resistor networks do? Well, we know that they can get voltage variations, and they can also have current variations. So we've got voltage division circuits and we've got current division circuits, meaning series circuits versus parallel circuits. All right. So, but right now we start out with have a 6.8 volt battery. So we know that periodically we've got to charge up that battery. How do we charge it up? Well, we've got a cord that we plug into the wall, hook up into the iPhone, okay, and it charges the battery up. Well, the battery is DC, but what comes out of the wall is AC. So how do we get from AC to DC? Okay, how do we charge this up? Can't really charge it up AC wise because it's a DC battery. All right, well, inside of the module that you plug into the wall, we know is a transformer. And we've studied transformers in the last course that we took. Okay, the transformer will change that 120 volts, we'll step it down to something in the range of 6.8 volts. Okay, so now coming out of the transformer will be 6.8 volts. Okay, we know how we can do that. We know that it takes a step-down transformer. We can figure out how many turns in the primary, how many turns in the secondary to get to 6.8. But what we get out of the secondary then is 6.8 volts AC. All right? We're not going to charge the battery up with a 6.8 volts AC. We've got to translate that into DC. Okay, and that's a future course. A future course, we will learn about solid-state devices such as diodes. Okay, Diodes are simply components that let current go through. Any current going through has to be in one direction only. So if we have AC current, we send it through a diode, and on the output of the diode, we get DC. So normally we've got in our charger, then we've got the transformer hooked up to what we call a diode bridge, okay, a rectifier bridge, because it takes our AC output from the transformer and rectifies it, and so that we get output from the bridge is DC. So we use that DC to power up our battery. So now we've got our battery that is fully charged, and now we're ready to be able to use it as a phone. Okay, how do we do? We dial a number on the phone, okay, and we talk into the microphone in the cell phone. The cell phone picks up vibrations from your voice, and they have many different frequencies. They can be high-pitched frequencies, very high tones, tweeter-like, okay, and they can be very low frequencies. There's a lower frequency, okay. So basically, what that does is pick up a frequency range, all right. But we said that this is a battery. This works on a battery, a DC. So somehow we have to create a way to get frequencies, okay, AC frequencies of distributed AC frequencies. We then take those AC frequencies and send them out. So then the iPhone then has to collect all that information, send it out to a transmitting unit. Okay, it's picked up by something, an antenna someplace, and passed on to a receiving somebody that we're trying to call, a receiver on their iPhone or cell phone. Okay, they receive that, and what they receive is a bunch of frequencies again, all right? But this is actually all done digitally now, all right? And that's another course, that's a future course that we have to take. Digitally is where we're taking everything, all this frequency information, and we're digitizing it so that we get 0 and 1s, okay? We get something that's 0 and 1s. Now we can do that very, very fast, okay? Very, very fast, because when we're talking about digital, digital is actually a square wave AC signal, and we can have that into megahertz, gigahertz, okay? We can do that megahertz, gigahertz. That's extremely fast. That can be down to a billionth of a second, okay? That's how fast it is. That's the speed of it. And so that we'll learn about that in future courses. Another thing that we will learn is we take pictures with the iPhone, all right? How do we take pictures? Well, in the iPhone, we have a certain chip, okay, that can absorb light, okay? And it looks like a transistor, but it absorbs light, and light is also a lot of frequencies, okay? So it picks up a lot of frequencies, and it picks up actually 3 different frequencies, red, blue, and yellow, I think it is, something like that. Okay, each red, blue, and yellow are different frequencies of light. Okay, they're picked up, And the chip itself has millions of these little, they're the capacitor-like transistors, okay, that pick up the different lights and then create a digital signal from it that's transmitted, okay, in the same way that voice is transmitted, okay. And so we can send a picture, or we can copy that picture onto something else that'll print it out for us. So we will learn a little bit more about that future things, but right now, just to be, what we're going to concentrate on is frequencies. This course is a lot about frequencies, okay, and how we can select frequencies. We can select a range of frequencies, which we call a bandwidth, okay, and deal with that. Or we can also figure out a way to just look at one specific frequency, okay, that we're really interested in. Okay, so that's what this subject will be studied for the next 2 weeks. Okay, but today we'll start out with a review of our DC signals, DC math, and we'll go into the AC math. We're using phasers. Tomorrow, we're going to change from phasers to a different system, okay, to a totally different system, complex numbers, which are imaginary numbers, because they are also a vector-like mathematics. We'll learn that tomorrow, and we'll talk about that tomorrow. But for now, let's just review what we know about DC, AC, phasers, and how to solve the different circuits. Okay.